Okay, for the final. Okay, for the final project, I think the most team, the topic, the paper for most of team are good, but team 13 and team 14 and the team 23rd, team 14 and 23rd, 第14个 team and 23 team. One is doing the unit, the other is doing YOLO V3. That's not good because that's too old. Unit is very good. Unit is very good, but it's too old. So you can try to find the paper about recent 4 years, the paper about recent 4 years. 找一下最近4年的 paper 就好了啦。是 unit 的改良嘛。You can try to find paper is modified unit, and don't use YOLO V3. Nobody use YOLO V3. You can use I don't know, 4 YOLO V4, V5, V7, something like that. 不要这样，那个 V3 没有那么好，这样子。好，所以再麻烦你们这2天把 paper 找上来了，还好啦。Okay, we'll back to here. So that's for training. And for the after training, you start to do the test. And for the test, they have actually 5 steps you need to consider, because actually 6 methods, 6 methods, and to solve usually over 15 problems. So we will consider early stop, we will consider graduation, dropout, and all try to design a new network with less parameters. Sometimes over 15 is because your data is not enough, but your parameters is too many. So you'll try to design a new network to reduce the number of parameters. And the fifth is to do more data. We call total data augmentation. Okay, and so I think it's 6 one is can do is for the transfer learning, something like that, transfer learning. 我忘记写那个 transfer learning. So what's the overfitting? Is this one, right? Overfitting is suppose you have a sample here, and you try to find the best regression line to fit this one. So this is the best result. The model, this is the blue line is the model. So the best result is the model fit into the ground truth function. Okay, the underfitting is this one. Your ground truth is the red one, but your model is far away from the result. Overfitting is that you want to get a perfect result. That's meaning your line, your curve will pass through each samples. That's for training. However, your test data won't be the same as the training data. So this curve is your best result, perfect result. But when you have a different kind of a little bit different of test data, you'll cause a lot of error. So best one is this one. Best one is what? You will allow some errors. 要允许它有一些错误这样子啊。Okay. So first solution is early stop. Is meaning, as I said, this epoch, this loss function. Your homework is this one. When epoch is loss function, this second is the epoch and the accuracy, right? Accuracy. Okay. So first one is the early stop is because your training data is here, right? And your validation data is here. That's because suppose you cannot see your test data. So if you do the epochs here, that means you have a good result of training. Your validation results become worse. Okay. So what you can do is don't do the perfect result here. You can before the perfect result here, you can stop. That's meaning when your validation error is your validation error is increasing, you should stop here. You don't need to have a lot of epoch. Okay, so early stop is this one to solve the overfitting problems. The second one, weight decay is weight decay. Is you have a weighting here. So that's meaning you can have a more iteration times. 你的 iteration 次数可以变多一点，然后你不要一次把它更新完，你慢慢就更新缓慢这样子啊，但是也不会很慢啦，因为你本来是1嘛，你用 0.99 类似这样子哈，所以这是 weight decay 的方式可以用。好 ，the third one is a dropout. That's meaning the weight for each one. The dropout is mean for each iteration you only pick up 50%. You only select 50% of cell for training. You just pick up 50%. You have 50% the cell for training. Other you just drop out. 那 drop 不是真的丢掉哦，是保留那个值不动。This iteration you won't count that one, but each W value is still there. I'll just keep it. Okay, so drop out. The last one is that we do data augmentation because you don't have enough data. Okay, and drop out like this way. Each time, okay, I randomly pick up. It's just right drop out 50%. They will do for you. So each time 50% of the cell will just frozen there, and the others keep going, keep updating. Okay, it's called drop out. 好，这个就讲完了。Okay, we talk about data augmentation. The data augmentation, the easy way is an original image. You to flip the mirror, 把它镜射过来。So you have two, one become two. And then you should use a crop, a little bit smaller window. For example, your original image size is 256 by 256. When you input, your image size will become 224 by 224. So this red one will shift to like here. Left top shift to here. Second, third, fourth, and the middle. So that's meaning each image you can increase to 5 times more. After you do the middle, you can the other 5 times of image. That's meaning if you do the data augmentation, your images, the total image size will become 10 times more than before. 就你用这个方式，你的资料可以增加10倍。那我的经验 ，my experience is how many training data is enough for training? 10,000. You need to have a 10,000, around 10,000 data, 1,000笔资料 for training. That's meaning what? That's meaning in your site, you need to have 1,000 images. 你要收集1000张影像。那1000张影像 you can after you do data augmentation become 10 times. 10 times. So will become 10,000. 就本来1张影像经过 data augmentation 也会变成10000张。这是我的经验，所以至少你要1000张。那1000张我再讲一遍，你有1000张影像 ，you do mirror 就变2倍了嘛，乘以2。那每一个这原来这影像2倍啊， 你这样一下你就这样 shift 5次，然后在中间就变5倍，那2个就是变10倍，所以 data 就增加10倍了这样子。1万张大概可以够 training 的。好 ，and here they use PCA because PCA can do the synthesis. But right now have a better result is GAN. GAN is better than the PCA. Here PCA is, I already teach you, PCA is the average value, right? And then you have eigen, this eigen vector, eigen image, and then times your weighting. So you control the weighting. You control the weighting will become new image. So use the GAN or PCA do the reconstruction. You can have increase more data. And based on the variance here, because PCA can create eigenvectors and average value. So this is the other way. Okay. And there's some result. So 大概还好. Okay, so that's for AXNet. We'll continue to teach you VGG16.